Hi, grade. Today we're going to be reviewing functions and linear and nonlinear functions. Alright, so what is our rule for a function? Our rule for a function is that every x has one y. And then when we're talking about functions, we cannot have y squared, but x squared is fine. Now we're talking about linear functions. What does that mean? A linear function needs to have a constant rate. When we're talking about constant rate, that means that it has a constant slope. And when we're looking at linear functions in an equation, that means that our equation must have no exponents, just like our equation of a line, which is y equals mx plus b. So let's go through these equations. Looking at the first equation, what do you notice about this equation? The first thing I notice is that there are no exponents, and I also notice that this equation is in our slope-intercept form, our y equals mx plus b form. So is this equation linear? Yes. Is it a function? Yes. Remember, all lines are functions. Now let's look at the next one. My y doesn't have any exponents, but my x does. Is this linear? No, because I still have exponents, so it's not a line, because it won't look like y equals mx plus b. But is it a function? Yeah. Next one, is it linear? Yes, because I have no exponents. Is it a function? Yes, all lines are functions. Last one, is this a function? No, it's not a function because I have my y squared, so is it linear? No, it won't be linear either because it has exponents. For this graph, is this graph linear? No, it is not linear, but is it a function? When we look at point number 3, how many outputs are there? Y could equal 2 or y could equal -1. So for that one input, you have this output and you also have this output. So it is not a function. And then remember that when we're talking about linear, we're just talking about a line. Are these points on a line? No, so that's why it's not linear. Is this graph linear? No, because it is not a line. Is it a function? No, because for some of these x values, you'll be able to go up as well as down to that point. So one input has more than one. Let's run through some equations. Is this equation linear? Yes. Is it a function? Yes, all lines are functions. Is this equation linear? No, we have an exponent. Is it a function? No, because we have y squared. Is this equation linear? Yes, because we have no exponents. Is it a function? Yes, all lines are functions. And you can even notice that it's in our y equals mx plus b form, where m would be the 1/4. Is this equation linear? This one's a little bit tricky, but this exponent is actually going to the x squared because of these parentheses. So the x does have an exponent, so it is not linear. Is it a function? Yeah, because we have x squared, not y squared. Is this graph linear? No, because it's not a line. Is it a function? No, because for this input, we go up to that and down to that. Same thing for this input right here. For your one x value, there's more than one y value. Is this graph linear? No, it's not a line. Is it a function? Yes, for every x value, there is only one y value. Is this graph linear? No. Is it a function? Yeah, for every x value, you have 2 possible y values. For this x value, you could go up here or you could go down there. Go ahead and finish up the rest of your worksheet independently.